So here the concept is the asynchronous serial transfer. Okay, basically what are the different kind of data transmission techniques we have? So possibly we have 4 types. So the first one is the asynchronous serial transfer, and the next one is the synchronous serial transfer, and asynchronous parallel transfer, and the synchronous parallel transfer. This is based on the 2 combinations, serial and the parallel, and again 2 more, synchronous and asynchronous. So based on this 2 into 2, we have 4 combinations. So altogether 4 combinations we have. So synchronous with serial, synchronous with parallel, asynchronous with serial, and asynchronous with parallel. So now I am going to discuss about the asynchronous serial transfer. So which is a one of the concept in your second unit. Okay, so asynchronous serial transfer. So as I told you previously, asynchronous. Asynchronous means there is no need of clock, isn't it? Synchronous means clock pulse we require. Based on the clock pulse, we are going to transfer the data. So there is no problem when we are going with the synchronous data transmission. So I think I told twice or thrice. So again, I am telling the same thing. When we are sending the data in the form of asynchronous mode of data transmission, we'll have the problem. So this one is like sending the data by inserting start and stop bits at the starting of the data transmission and at the end of the data transmission. As there is no clock pulse, like we are having start means used for indicating the start of the data transmission, and the stop used for indicating the end of the data transmission. So in between whatever the data we have, so that will be considered as a valid data. Are you clear?
Yes, sir. Yes, sir.
So the start and the stop bits in between, we will add some data. So that data we are considering it as a valid data. So this kind of data transmission is called as an asynchronous serial transfer. Okay, what are the things you will have? Start bit, data bit, stop bit. Fine. So whatever the data is a valid data, we will consider in between the start bit and stop bit. Okay.
Okay. Yes, sir. Yes, sir.
Yes, sir.
This type of data transmission is called what?
Asynchronous transfer.
Serial transfer.
Okay, so asynchronous serial transfers. Why we are calling it as a serial? As we are sending the bit by bit data, we are calling it as a serial data transmission. Okay, so this is one of the small concept. You will get it for the 2 marks. Okay, what is the asynchronous serial transfer? So, or else, so can you give the bit sequence of the asynchronous serial transfer? Fine. So the next concept is, and this one is important concept, and the asynchronous communication interface. So as I posted in the group as well, so one of the long answer which you can expect from this concept is draw the block diagram of asynchronous communication interface. Okay, actually this one we are calling it as a UART, so Universal Asynchronous Receiver and the Transmitter. What it is? UART. Okay, Universal Asynchronous Receiver and Transmitter. So what is this unit? What it will do? So the basic use of this Universal Asynchronous Receiver and Transmitter section is, it is used to transfer the serial data transmission. Okay, it is used for transmitting the serial data between the CPU and the IO devices. Are you following?
Yes, sir. Yes, sir.
It is mainly used for transmitting the serial data between the source, between the CPU and the peripheral devices. Fine. And are you able to see the block diagram on the screen?
Yes, sir. Yes, sir.
What I told, what it is, which block diagram?
Universal asynchronous data receiver and transmitter.
Universal asynchronous receiver and transmitter section. Okay. So
Yes, sir.
this typical unit mainly consists of 4 registers. You have to follow my explanation carefully. Okay, this typical unit mainly consists of 4 registers. So the 4 registers are transmitter register, control register, status register, and receiver register. So as it is already there on the screen. Okay, so the transmitter, control, status, and the receiver register. Okay, and it consists of one data bus buffer and one timing and control unit. Okay, so and next The supporting registers which we will use here is the shift register and the timing and control unit status. So the supporting registers which we are going to use here are shift register and some of the timing and control unit registers. So first I'll start my explanation with the bus buffer, data bus buffer. So the main usage of this block diagram is to transfer the serial data transmission in between the CPU and the peripheral devices. Okay, so that is the main usage of this UART. Serial mode of data transmission, I can say asynchronous serial mode of data transmission. Fine. So the first one is the bus buffer. So what is bus? What is the bus?
Bus means which is used to carry the information.
Carry the information. So this bus, whatever I am using here, we are calling it as a data bus. So data bus means which is responsible for sending the data from the microprocessor to the peripheral devices. So clearly you can see data bus bidirectional. What is bidirectional?
Directions in both directions.
Two directions.
Two direction means what? The bidirection is like it can send the data and it can receive the data
And
at
receive.
the same time. So that we are calling it as a bidirectional. So that bidirectional data bus we are using for sending and receiving the data. Fine. And which is connected to your internal system bus. From that internal system bus. So the internal system bus is again consists of data bus, address bus, control bus. Fine. It consists of data bus, address bus, control bus. 3 buses. So which are mainly used for performing the data transmission and performing the different operations. Are you clear?
Yes, sir. Yes, sir.
You need to explain the typical units of this block diagram. The first unit is the data bus buffer. Data bus buffer is responsible for transmitting the bidirectional data in between the microprocessor to the peripheral devices with the help of the internal system bus. That we are going to write. Okay.
Yes, sir. Yes, sir.
And next one, timing and control unit. So what is this timing and control unit? So the timing and control unit is responsible for issuing the timing signals, okay, and to perform the different operations. It is like performing read operation, write operation, and which register I have to select at what time I have to select. So these all will comes under the timing and control unit, okay, which will be monitored by the control register. Are you clear?
Yes, sir. Yes, sir.
So what are the signals we have under the timing and control unit?
Input output read, input output write.
And
Chip register.
Register
Chip
select and
sir. Chip select.
Chip select. So we have the 4 possible signals: chip select, register select, IO read, and IO write. Okay. So in this we will make use of 2 signals together. That is chip select and the register select. Okay, these 2 signals we will use simultaneously. Why? Because based on these 2 signals we are going to select the different kind of the registers and the different kind of the operations. Okay, so down you can see the table. So CS and RS it is there, isn't it? If it is 0 and the no operation, cross means no operation, there is no operation. That means we are not doing anything. So CS and having 0 and RS is X, then what it will indicate?
No operation.
No operation. And what it is telling? Which register is selected? There is nothing selected.
None. Sir.
There is nothing selected and data bus is in high impedance. What is this high impedance? High impedance is always active. Okay, the signal is always active. Whenever you want to use, you can use it. Fine. So that we are calling it as an high impedance state. Are you clear? And down you have one more, 1 0 1 1 1 0 1 1. Did you notice anything here? Same repetition of signals and values is there. You see 1 0 1 1 1 0 1 1. So previously we can find 0 0 0 1 1 0 1 1, isn't it?
Yes, sir.
But here we have 1 0 1 1 1 0 1 1. That means chip select 1 is 1 and RS is 0. Then we are calling it as a write operation, and at that time it can select the transmitter register. So accordingly, based on the different values, it will select the registers. Are you clear? According
Yes,
to
sir.
the different values, so it will select the different register. So 1011, 1011. You can see transmitter register and write operations. So here two are the write and two are the read operations which we are going to perform. Okay, I can say it as write only and the read only. Fine. So I can say it as a write only and read only. Two write only registers we have and two read only registers we have. What are the two write only registers? What are the two write only registers? The two write only registers are the transmitter register and the control register, and two read only registers are the receiver register and the state. Are you able to hear me?
Yes, sir.
Yes, sir. We are able to hear.
So we have two write only and two read only registers we have. So those are two write and two read. Those are the transmitter and the control register, and the receiver and the status register. So this is with respect to the registers, so which are purely based on the timing and control unit. Okay, and the next one, if you want to perform any operation with this interface, we should load the control word into control register. The control word is nothing but what type of operation we are performing. So that will be indicated by the control word. If you load the control word into control register, okay, then the transmitter and the receiver will get activated. Okay, once the transmitter and receiver section is activated, so you are able to see the shift register for the both transmitter and the receiver, common register, isn't it? So the shift registers are the common register.
Yes, sir.
So here the shift register transmitter is sending out data, means the CPU to the outside, and the receiver is taking data from the outside to the CPU. That is the meaning for the arrows. One is going from the CPU to out, so which is going transmit, and one is coming from the out to inside, so which we are calling it as a receiver. Okay, so the shift register is mainly used for tracking the information. Okay, so which bit I need to shift next. Okay, which bit I need to shift next. So that will be tracked by the shift registers which are assigned with the transmitter and the receiver section. Are you clear?
Yes, sir.
Okay, the shift register is used for mainly tracking the serial data transmission which the transmitter is sending next, and which the receiver is receiving next. And then along with that we have the transmitter control and the clock, and the receiver control and the clock. So these two are mainly responsible for the providing the clock signals for the transmitter section and providing the clock signal for the receiver section. Why it is a need of providing clock signal? Just it's simply how much time it will take for sending and receiving the data. So that will be based on the clock signal. Suppose if it is transferring, so we can say it will take 5 minutes, and the receiver also will take the 5 minutes. So to track that kind of information, like we are making use of some kind of clock signals. So the transmitter control and receiver control will be personally monitored with the help of the clock signals. Okay, and what is the status register? The status register is used for identifying whether the device is busy or whether the device is having error, and whether the transmitter and the receiver is successfully receiving the data or not. So to identify this kind of scenarios, we are having the status register, which will work in synchronization with timing and control unit. So based on this status register values, the transmitter and the receiver can send or can receive the data. If you want to activate this device, this interface, you will load the data into the control register. Okay, so first you need to explain about the data bus buffer, and next you need to explain about the timing and control unit, and the following are the registers available in this communication interface: transmitter, control, status and receiver register, and the shift register is used for monitoring the data transmission, serial data transmission from the CPU to the IO device. And the entire communication interface is having 2 read-only registers, 2 write-only registers. So the 2 marks question you can expect from this concept is, what are the read-only and write-only registers of the UART? So those are transmitter and the control register, and receiver and the status registers. Fine?
Yes, sir. Yes, sir.